Hello, everyone. My name is Fabian Castro. I am a fourth-year graduate student here at the University of Texas at Dallas. Today, I will be presenting to you our work by the title Humoral Response Framework Encapsulated Whole-Cell Vaccines Enhance Humoral Immunity Against Bacterial Infection. I would like to begin my talk real quick, talking about bacterial infections in general. Let us remind ourselves that bacteria has basically the ability to infect virtually every tissue in our body. Just this four world endemics that I've listed in my slide here account for approximately 200 billion dead worldwide. It was then until 1928 when Dr. Fleming discovered antibiotics and bacterial infections were finally controlled by modern medicine. However, more recently, bacteria have found ways to bypass or to become resistant to this antibiotic, complicating the scenario again. Let's take, for example, urinary tract infections, whose primary cause is uropathogenic bacteria. We have this bacteria that colonizes the bladder. If left undertreated or basically untreated, it will find its way into the kidneys and then cross into the bloodstream and generate very severe problems. Unfortunately, some of this bacteria, though treated, like I said before, still find ways to remain in the bladder. Some very interesting statistics shows that 80% of all women will experience a urinary tract infection throughout their life, and 40% of these patients, unfortunately, will experience recurrent infections. So clearly, we need better platforms to establish pre-infection care. And what are the other options available? We have vaccines. In the realm of bacterial infections, there's 3 different vaccine platforms that are currently investigated. We have attenuated, which themselves elicit very strong immune responses. However, the pathogen is still active, it's metabolically active, and has the ability to mutate. We have subunit vaccines, in which you recognize a piece of a pathogen, you introduce it into a body. However, these vaccine platforms are known to elicit poor T-cell responses, which will eventually translate in poor antibody production. We finally have whole-cell vaccines, which I will be talking about throughout my talk today. So what we did, we took a metal organic framework. For those of you that are unaware of what a metal organic framework is, these are coordination polymers that are constructed between the interaction of a metal ion and an organic linker. There's a wide variety of them, which have been forever used for industrial applications. However, more recently, these have been used for more biologically relevant applications. In our case, we use ZIF-8, which is constructed between zinc, and 2-methyl imidazole. It is biodegradable, quite biocompatible, and again, been widely used for biologically relevant applications. So this is our project overview, which was divided into 2 stages. The first one was encapsulation of the pathogen. Very important for me to mention that we work with a uropathogenic E. coli widely reported in literature, known as CFT073. We encapsulated it in the coordination polymer, characterized the material, made sure that the bacteria was inactivated, and tested uptake and cytotoxicity. We then moved into the second stage of the project, which included vaccination in murine models and characterization of both humoral and the cell-mediated responses. Important to mention, we were very happy to find that the crystallinity of the material was not lost by encapsulation of the bacteria. This was confirmed by powder X-ray diffraction, and also we did elemental analyses to kind of map which transition metals and what elements were present in solution. We then looked at the bacterial inactivation. As you can see here, the bacteria by itself is quite capable of growing in LB agar, whereas the bacteria that had been encapsulated in the moth, and after removal of the moth, the bacteria no longer grew. We took a closer look at this phenomenon and came to the conclusion that in the zinc-rich environment, we promoted this mismetallation process that inhibited the bacteria from growing. We looked then at the half-life in vivo. We introduced a plasmid that encodes for a encodes for a red fluorescent protein that is widely used for in vivo applications. And we benchmark our work against commonly inactivating processes such as formalin fixation that are, again, widely reported in literature. Very happy to find out that encapsulation within the moth promoted a longer half-life in vivo for the bacteria. We vaccinated the mice with 3 rounds of the composite and took blood day 14, day 21, and day 42. Quantified IL-6 production, and we are very happy to find that the ZIF-encapsulated composites or bacteria promoted the higher concentration of IL-6 in serum. The same we did at day 21 and day 42. This case, however, measured IgG production, and as you can see from the panel, the composite promoted greater titers for the bacteria. We then extracted lymph and spleen and looked at B cell, T cell, CD4, and CD8 populations. And again, very happy to find out that the ZIF composite outcompeted the saline and the CFD fixed. We did also germinal center, class switching, and light zone and dark zone ratios. And in all of them, we were able to find out that the ZIF had promoted the greater counts. Our experiment then shifted into a more cell-mediated response quantification. We looked at pro-inflammatory cytokines, Th1 mediated, and very happy to find out that the ZIF promoted higher counts for this as well. We looked at IL-17 and IL-4, and again, happy to find that there was significance between the groups and that the ZIF mediated a stronger cytokine production as well. Our experiments concluded with a bacteremia challenge experiment in which after vaccination, the mice were injected with a lethal dose of bacteria. And we were very happy to find that the mice injected with the ZIF composite lasted for 48 hours. At the end of this period, the liver, spleen, and blood were plated in agar. And we're very, very excited to find out that the lower bacterial load was found for the ZIF-encapsulated composites. With that, I would like to conclude my presentation thanking everyone that participated, especially our funding agencies. Thank you so much.